All right, here we go. Population density. It has to do with area. That's why it's in this unit. It is a small formula. It's the population over the land area. Do you guys discuss this at all in science class? Population density? Maybe density, but not population density. Here's what I think about. Think about a small piece of land with a ton of people. A small piece of land with a ton of people, that would have a high population density. Or think about the opposite side. Let's think about a huge piece of land, very few people. That would have a low population density. All right, so what I always do with this is states right off the bat. What state do you think has the highest population density in the United States? And which state do you think has the lowest population density before we start calculating any of these? Predictions here without looking anything up. A state with the highest, now highest would mean small area, a lot of people. Low population density would mean big plot of land, not many people in there, not many people. I may have to look, I know the highest one, but I might have to look up the lowest one. Guesses, Andrew? For what? Highest? Carolyn? All right. Anybody, was that AK? Anybody know the abbreviation AK? Because AL, I think, is Alabama. Other guesses, Matt, what do you got? Little NJ, huh? Other guesses here, more guesses. Highest, lowest, we're just going with Montana for what? Lowest, little MT. South Dakota. James? Little ID. What do you got, Madeline? California. What do we got over there? Now you're going from Rhode Island to Florida? Ella? City's pretty packed, as you can see down here in this example. Yep. Maya? Wyoming. Okay. I believe somebody picked the highest one. All right. I'm just going to double check here, but I believe New Jersey is the one with the highest population density. Let me just check. States. Yep. Two. This was in 2005, though. Well, district. Okay, District Oakland. We're not counting that as a state, but yes, looks like New Jersey. Yep. Nice job. Are we going deep here? Going deep. Alaska. There it is. Alaska. Nice job. The lowest one. Yep. Wyoming, pretty close. Montana. You guys had it. South Dakota. You guys were in there. What do we got? New Jersey, Rhode Island. You guys are there. Mass, Connecticut. So all the New England states. All right, there you go. Okay, so how do I calculate this population density? I take the population of the area, I take the population, and I divide it by the land area. All right, so I took the 5 boroughs of New York City. Which one's got the highest? Which one's got the lowest population density? Before calculating, do you think you could guess just by looking at the numbers? Which one would have the highest? Which one would have the lowest? Do you think you would be able to guess? Frank? You think Manhattan's the highest, and what do we think is the lowest then here? A little Staten Island. All right, well, let's find out. Go ahead. Find out the population densities, if you haven't already, of Brooklyn, Manhattan, Queens, Staten Island, and the Bronx. You take the population and divide it by the land area. Highest one ended up being, yep, highest one ended up being Manhattan. I would say about 67,000 people per square mile. All right, and if you want, I don't know, the visual, you go a mile by a mile, get a square right now, that's a mile by a mile on both sides, 67,000 people fit in there for Manhattan anyway, versus Staten Island, only about 7,600 people, all right, would fit in that mile by mile square. All right, we okay there? Okay, how's this show up on the Regents exam? Well, that's the next example I gave you. It shows up, oh, January 2016. That's kind of a familiar one. That's the one you guys have right now. All right, that's one of them in the packet you have. This is where population density ended up. We got Petri dish A and B. You guys see the population of the, what do we got, bacteria. Oh, that's perfect. In the Petri dishes, which Petri dish has the greatest population density? And no, I'm not just picking B because it's bigger. All right, which one has the greater population density? So remember, population density, we have a formula for. Population over area. Population is given in each Petri dish. What is not? The area of each Petri dish. All right, each Petri dish is in the form of a circle, which I'd given you that formula yesterday. So somebody help me with Petri dish A. Population, I can do that one, 40,000 over the area of the Petri dish. It's a circle. Remind yourself, what's the area of a circle? Essential maintenance on Sun. Oh, good thing we won't be here. Wonder if we'll have some new features. 6. Anybody remember the formula for circle? Pi r squared. What's given in there, Stacy? What's that 51 representing? Diameter. So I want to do 40,000 divided by pi, not 51 squared, but 25.5 squared. Yep. And the same thing goes with Petri dish B, but now I'm going to do 72,000 over pi times 75 divided by 2. 37.5 squared. Okay, what are you guys finding for each Petri dish here? 11 each Petri dish? Yep. So 19.58 bacteria per millimeters. Yep. And then over here? 16.3. Yep. So which had the greater population density? Petri dish A. Okay, again, actual Regents question that showed up. All good on the population density. All right, so you guys will have page 6 for homework tonight. You're going to actually do a little concert, go to a concert tonight and answer some questions. Anything on the population density? New Jersey, Alaska. There you go. There's your fun fact for the day. All right, we got the rest of the basic figures to talk about. Trapezoid, rhombus, kite. Quick review of their areas if you need to go look them back up. Trapezoid formula, 1/2 the height times the sum of the parallel bases. B1, B2. We wrote that one down yesterday. And the good thing about today, rhombus and kite, actually, I didn't go over rhombus, did I, yesterday? Yeah, we did. It was rhombus / kite. It had the same area. 1/2 the product of the diagonals. That's what D represents up there, the product of their diagonals. All right, so here we go. Let's go over a couple basics before we get tough like usual. Here's a kite. So I remember the area formula 1/2 D1 D2. It's the whole diagonal. D represents the whole diagonals up here. So give me the length of both diagonals up here. Here you go, 20 length of both diagonals. So 1/2 of 20, the longer one, times 16, the shorter one. And just like yesterday, make sure we're confident in our units and we write them down every time, square centimeters, okay? All right, rhombus now. One diagonal measures 6 feet. The area is 48. What's the measure of the other one? Okay, we are talking about a rhombus, and it did give me the area, so 1/2 D1 D2. Can I get a little help from you guys? What should I plug in here? What should I plug in? Here you go, 3. What should I plug in? Nice job, 48 for the area. 1/2, do I know anything else? What's one diagonal length? Yep, so I can plug that in for either D1 or D2, doesn't matter. And I'm solving for the other diagonal. You can put X in there if you want. So 48 is equal to 3 times the other diagonal. Okay, other diagonal then. I'm not going to ask anybody. 16 feet. What did I do?
Do you distribute the 1/2 to the diagonal, or just?
What do you mean? There's no, if there was a plus, that's all multiplication,
Oh, okay.
right? If there was 6 plus D2, then yeah, I would distribute it. But since it's all multiplication, it doesn't matter which one you multiply. Good question. We all good? All right, now we actually have to use some properties of a rhombus here. Find the area of this rhombus. Okay, so 1/2 D1 D2. Can you guys help me get to the lengths of the diagonals? What properties of a rhombus could I apply here that would find the diagonal lengths? Any properties we could apply here that's going to get me, and I have a hint that says Pythagorean theorem may be helpful, but we're not to that point yet. Rhombus properties. Any rhombus properties you want to throw out that may help us? Nate? Yes, they do. Diagonals bisect each other. So you're telling me this 40 is congruent to this 40, which would make one diagonal at least a length of 80 inches. All right, what about the other diagonal? Diagonals bisect each other. What else in a rhombus? Madeline? They're perpendicular. That's why I have this up here with Pythag. They are perpendicular to each other. So now you could find this length right here, and you know it's getting bisected, so I could double it and find the other diagonal. All right, I always get nervous when you try to set up Pythag and the hypotenuse is given. What's it going to look like? 27, what's Pythag going to look like?
A squared plus 40 squared equals 50 squared.
Good. Notice the 50 is the hypotenuse, so it goes in for c squared. What is half that diagonal anyway? 14. What do you end up getting half the diagonal? I'm actually surprised that I'm picking numbers that people that are here. What do you got, Nate? 30. Yep. A came out to be 30. So, Nate, what's the whole diagonal then? 60 inches. Yep. There you go. And what do we end up with? 2,400. Square inches. Units, units, units. All right. Any concerns from you guys before we go trap now? Trapezoid. All right, let's do it. Trapezoid. Simplest radical form for our answer. Go back, look up the trapezoid formula, 1/2 height. Sum of the bases. We're going to have to do a little extra work with the trapezoid. Oh. Any of these that you know, height or the bases, any of them I gave you right off the bat. 25, any I gave you? Yes, we do. We have 6 and 11. All right, what's the deal with the height now? Height comes from a vertice perpendicular to the opposite side. Could we find this height? Sure. Is there another height we could draw in that might be a little bit easier to find? Coming from B, perpendicular to DC. That might be a little easier to find because that's part of a 45, 45, 90. 6, 6. Give me the side in the 45, 45 now. 5, yep. I don't think I need to break out the chart here. Where's the 5 across from in the 45, 45, 90? 12, where's that 5 across from? What's across from the other 45 then? The height, which is 5. They're both congruent. And now I'm on my way. 1/2 times 5 times 17. $42.5, everyone, 42.5. And if there's no units, I wouldn't expect, don't pull, I hate this. U squared, units squared. No, there's no units, you don't have to put any on. Anybody wanted to do that a different way than using the trapezoid formula? Let's talk about that way real quick. If you didn't want to use the trapezoid formula, I already kind of did it. I broke it up already. Go ahead, Rose. What could you have done?
I split it into the rectangle with
Yep. There you go. Area of the triangle, 1/2 base times height. Area of the rectangle, length times width, and add them together. That's also very, very feasible. All right, no problem. All right, B, how about this trapezoid? 1/2 the height, base 1 plus base 2. All right, anything given to you here? Anything given? 22, anything given? Who struck out? 9? Okay. 7 plus 11. All right, help me find the height, everybody. I'm going to draw it down from P to RQ in a 30-60. 7, 7. That must mean the side in the 30-60 is 4. I just got to figure out the height now. $17, find the height there using the 30-60-90 rules. Nice job, 4 radical 3. Okay, it does say simplest radical form. Let me help you with the algebra now. So I have 1/2, I have 4 radical 3, and I have 18. What do you want to do algebraically here? Because I got to keep the radical 3 there. So ready? 1/2 times 4. 2. 2 times 18. Okay, keep the radical with it. 36 radical 3. You can multiply anything with radicals. You just can't add and subtract different radicals. All right, I told you guys yesterday I'm going to try this more and more, and this is to try to let you guys figure out this challenge one on your own here. All right, what's the area of Amelia's team pennant? Obviously, it's Team E. Aaron, Amelia, and Elena. That's cute. The team with the edge. All right, I'll stop. You guys can talk to each other. It's all right. May want to bounce some ideas off each other here. Find the area of that, because I did not give you the bases here. I gave you one base is 10. That's it. That's all you know. One parallel base is 10. Go after it. Get after it. Talk it over, honors. Okay, just some thought here. I don't know how many of you went about it. I drew a height down from here to here. All right, from this vertice perpendicular down. I made a rectangle, so I knew that was 4, that was 4. All right, everyone with me so far? I performed Pythagorean theorem on this right triangle right here, the one I highlighted in yellow. So that's why you see 4 squared. Trying to solve for b, which is this leg right here, with 8.5 as the hypotenuse. Because once I found b, how can I find the rest of this part here, which is the same as this base here that I need, this missing base that I need to fill in. Here's what b ended up being. What do I do with 10 in the b value of here to find this remaining length here? Subtract the 2. All right, so that was going to be 10 minus the square root of 56.25, which should have ended up being, what was that, 2.5? All right, this other 2.5, so the opposite side, the other base had to have been 2.5. And the final area, what did we end up with? Final area? (25 square inches). We okay there? That was a little bit tougher. All right, that was a little tougher. Just couldn't do a 30-60 or 45-45 there. Anything from you guys you want to go over? All right, you know where we're going now. Let's get the regents out. And your compass, and your compass. I'm going to question 34. And what do they give me? They just give me a line at the bottom? Okay. You can use the back of your calculator if you need to. That's one thing that drives me nuts, but we don't have the time to pass out straight edges or anything. All right, here's what it's asking. Take XYZ, copy it onto this line, so ABC and XYZ are congruent. And state the theorem that justifies Y. Well, how many theorems are out there that say two triangles are congruent? How many theorems are out there? 5. What are they? Let's review. What are they? Side, side, side. So I could copy all 3 sides. What else? Side, angle, side. HL, I don't think I'm going to do here. Anybody know why? It's not a right triangle, so that's not a possibility. But what about the angles now? Angle, angle, side, and angle, side, angle. All right, so we could do any of these 4 right now and copy them onto here. For our purposes, I think side, angle, side might be the easiest. All right, so side, angle, side. First thing we need to copy is a side. All right, preferably, probably the easiest one to copy onto here is going to be, it doesn't matter the order, but XY. Okay, so everyone copy XY. And now start labeling your points, A and B. Because remember, this triangle's got to match up with XYZ in the correct order. So I measure XY. I'm just going to make, because this is a line, I'm just going to make a random point on here. There you go. That's going to be point A because X matches up with A. And I'm going to make my arc here. And that'll be B. Everyone all set now? Because now we got to go angle. We got to copy angle X over here on the A. All right, everyone ready? Okay, it's been a while. It's been a while. Take your compass, put it on vertex X, or whatever angle you're copying. I just think it's easier to do it this way. Anybody remember what to do from here? Make an arc that intersects it, both sides. 1, 2. What's X match up with? A. Okay, so I want to bring my compass down to A. And I want to make sure I make an arc now that intersects the ray. All right, so I'm going to make my arc. Whoop, come on now. Act like you've been there. Boom. Anybody remember what we have to do now? Go back up. Measure the opening. No arc marks needed, just measure the opening. Now here's the key. Do I go back to point A? Anybody remember where I go back to? I do not go back to point A. And I'm not going to point B. I go back to where this arc intersected that ray. So right here, I'm going to go back to. And I'm going to make an, some of us may need to make that arc a little longer, that one we copied from the angle. May need to make it a little longer. Draw in your angle. That's congruent to X. And we're almost home. Hey, side angle. What other side must I copy to do side angle side then? Okay, XZ. And where's XZ going to get copied? Right on the ray you just drew for the angle. So take XZ, copy it onto here, and that'll be point C. And I connect point C with point D. Finish it up if you have to. Let's go. Finish it up.